some more simple examples where the resistances, they are in series, they are in parallel or in combination of the two. Like over here, between A and B, if we have to find the equivalent resistance, this is R3, R1 and R2, they are over here. So we see that is R1 and R2, they are in series, and these two, they are in parallel with this. So first is we can find the R1 and R2, we can just add it and we can find the equivalent resistance of R1 and R2, that is R dash is going to be R1 plus R2. Once we find it, then this and this, they are in parallel. We can use the formula for parallel equivalent resistance, that is 1 by R1 plus 1 by R2, etc. And from there we can find the equivalent resistance between A and B. If we have, let's say, something like this. This is A and B. If we have to find the equivalent resistance between A and B, we see that these two resistors, they are in series. This and this resistor, they are in parallel. We can find the equivalent resistance of this. And then this and this, they are in series, and we can find the equivalent resistance. Now let's say in this we have to find the equivalent resistance between B and C. So over here we see that is this 7 ohm and 3 ohm, they are joined end to end. So these two resistors, they are in series. 7 plus 3, that makes 10. So we can remove this, and between this terminal and between this end and this end, we can add one more resistor, 7 plus 3, that is equal to 10 ohm. We also see now that is at C, and let's call it a D, between C and D, these two resistors, they split over here and they are joining over here, or you can say they split over here and they once again they reunite at the same point. When the resistors, they are splitting at one point and they are reuniting also at one place, then these resistances, they are in parallel. So over here 10 ohm and 10 ohm between C and D, these two, they are parallel. So equivalent resistance is 1 by 10 plus 1 by 10 is equal to 1 by R equivalent. So this comes out to be 5 ohm. So this is now 5 ohm. So the circuit is simplified so far. Now we have to find the equivalent resistance between B and C. We have to find the equivalent resistance between B and C. That is, it means that current is, let's say it enters from here and the current will be coming out from here. So we see that is 5 ohm and 5 ohm, they are in series. So we can replace them by one single resistor of, let's say, 10 ohm. 5 plus 5, 10. Now this 4 ohm and 10 ohm, they are parallel. So we can find 1 R equivalent is equal to 1 by 4 plus 1 by 10. We can solve to get the answer, that is what is the equivalent resistance between B and C.